Woohoo! We are live. This is Math 60 Intermediate Algebra. We're in section 3.2 and we're talking about substitution and elimination. Both are ways of solving systems of equations. And what I want to do before we go any further is to talk through some theory. Now, this is not required. This is something that you will revisit if you continue on in math. I just want to throw something out at you. And if it sticks, awesome. And if it doesn't, forget it ever happened. You know, extra knowledge, it hopefully can't hurt you, right? Matt Damon, right? He agrees with me. He's very serious. This is theory. Okay, so right in the beginning, ignore all the rest of this. Assume that A and B are equal and C and D are equal. That's all you have to remember. A equals B, C equals D. They're twins. Okay. Now, starting with A equals B, if I add C to both sides, I get A plus C equals B plus C. Do you agree that that's true? Because it's C on both sides. Okay. Now, here's where I do the little switcheroo. A plus C stays the same. B plus C becomes B plus D. And you're like, what? But C and D are equal. So since C and D are equal, I can replace C with D because they're twins. Then I get A plus C equals B plus D. Okay, so what? Well, what ends up happening is it looks like what you did was you lined up the equals. So you line up the equals. Again, my pen's a little too fat for this. Maybe Matt Damon can help us with this. If you line up the equals, I've got A on one side, B on the other, C on one side, D on the other. And on the left, if I add down, I get A plus C. On the right, I get B plus D. So this looks like this. So instead of remembering all of this, the way we say it is we say we're going to add these two equations. Now, we're not really adding the equations. What we're doing is we're not doing all this work. We're just using a shorthand. So instead of calling someone, instead of calling someone Catherine, which is long, and most people don't make it all the way through the word, you could call me Cat. And that's a way to just do it faster and quicker, and you don't have to worry about all of this. Woohoo! So this is what we're going to be doing. Now, again, I'm hoping that you've seen this before, but we are going to go through a little bit more because this tends to be the rustier of the two algebraic techniques. So I'm going to go through a whack ton of problems. You guys ready? Woohoo! Let's do it. Yay! Okay, so we've got a system of equations. We've got Matt Damon stuck and he wants to come home and he's like, hey, can I come home? And we're like, I don't know. Let's see if we can build you a spaceship that will work. So I've got these two equations, 2x plus y equals 6, and another one, x minus y equals 3. And remember that each of these represents or is represented by a graph of a line. And we're hoping that they intersect in an x because then, here, let me do it this way. Happy Matt Damon, right? Because the point of intersection is the solution. Sad Matt Damon. If they're parallel, there's no intersection. Happy Matt Damon if they're actually the same line. So that's what we're looking for. So what I'm going to do is, again, notice that, see what color, I'll use pink. Notice that I line up the equals. You got to line up the equals. You don't line up the equals, it gets very messy very quickly. You've got to shake off the rabbit fur if you have any rabbit fur, and you're going to put a plus sign there. Now, you're not really adding the equations. Again, this is shorthand. This is like a nickname for what's really happening. But let's go ahead and add. I'm going to add the left sides on the left and the right sides on the right. So I'm going to do the right side first because that's 6 plus 3 or 9. You can go directly to 9 if you like. And then over here, I've got 2x plus x. That's 3x. And then plus y minus y. Wait a minute, plus y, y is y. The y's cancel out. So I've got 3x equals 9, or x equals 3. So notice that instead of solving for one variable, substituting it in, solving that, no muss, no fuss, bing, bang, boom, and I've got x. Now I still have to find y, so let's find y. And the downside to this one is I don't have any nice equations. I'm going to have to use one of these two. So I'll just go ahead and use the top one. You can choose either one, does not matter. Plug in x. So 6 plus y equals 6. Subtract 6 from both sides. Everyone starts to panic. They're like, wait, what happens when everything's gone? And the answer is there's nothing there. Y equals 0. Okay, so x equals 3, y equals 0. Let's check. Oh, and we can write it like 3, 0 if we want. Let's check. Now, 2x plus y equals 6. 2 times 3 plus 0. Does that equal 6? 6 plus 0 equals 6. Yup. Okay, what about the other one? X minus y equals 3. So does 3 minus 0 equal 3? Yep. And we're done. Bing, bang, boom. Generally speaking, I do encourage you to put boxes around solutions when you're doing a solving, either elimination or substitution, just because they get so messy. It's easier. It looks just polished to put your answer there. So technically speaking, I will give you a hint. Not just a hint, it's a special deal. The special deal is that when you use elimination, because when you find y, you're always using an original equation. See how I use the original one right there? You don't have to check this one. Now, do I think it's a good idea to check both? Absolutely. I would encourage you to check both all the time. But you aren't necessarily required to do so. Whichever one you use to solve for y here, we don't have to check there. That's generally accepted. But check with your teacher. Your mileage may vary. So happy Matt Damon, sad Matt Damon. Happy Matt Damon. Woohoo, we got an answer. Woohoo, he's happy. He's got a spaceship coming. Okay, next up, let's see if we've got another interesting problem. I meet the most interesting people here. 5x minus 3y equals 8. Negative 5x plus y equals 4. I add them together. Magically, 5x minus 5x, bam, that's 0. Over here, I've got negative 3y plus y is negative 2y. 8 plus 4 equals 12. And again, I'm going to take you to Smeary Town just a little bit. The equals are all lined up. Make sure your equals are all lined up. So negative 2y divided by negative 2 equals 12 divided by negative 12. Y equals negative 6. We have to find x. I'm going to go ahead and use the first equation. 5x minus 3y equals 8. Let's see, 5x minus 3 times negative 6 equals 8. 5x plus 18 equals 8. Subtract 18. 5x equals negative 10. 5x over 5 equals negative 10 over 5. 5x over 5 equals negative 10 over 5. X equals what? Negative 2. Woohoo! X equals negative 2. Y equals negative 6. Oh, and I'll build a little addition there for the ordered pair form. Okay, what should we do? Check. Isn't this wonderful? Don't you love this? This is so great. Okay, I'm going to check both of them just so you get an experience of checking both of them. It's pretty fast. 5 times negative 2 minus 3 times negative 6. Does that equal 8? That's negative 10 plus 18. That's 8. Woohoo! That one works. Let's try the other one. Negative 5x plus y equals 4. Negative 5 times negative 2 plus negative 6. Does that equal 4? So this negative 5 times negative 2 is 10. You got it. Minus 6 is 4. Absolutely. Is Matt Damon happy? Yes, he's got an answer. Happy Matt Damon. Woohoo. Happy Matt Damon. It's a single solution. Okay, you guys ready? I mean, this is... Wouldn't you love it if math is just always like this? Wouldn't that be awesome? Do you know what the one thing you're not supposed to do in math? You're never supposed to say, this is so awesome, this makes perfect sense, because what's going to happen the very next one? Bwahaha. 10a plus 6b equals 6. 4a plus 3b equals 3. Add them together. Line up the equals. I'm getting good at this. Over here I get 9. Over here I get 14a. And over here I get, oh no. Oh no, nothing canceled. So here's the thing. The first two problems we did were nice. They were so nice, but most problems are not nice. Problems are usually fairly respectful, but you gotta come to them, you know, ready to do what needs to be done. So here we're gonna have to do what needs to be done. And so this is what it makes elimination really interesting. And actually, it's the reason that I really like elimination. But if you've never done this before, this is going to feel a little bit freaky. So this is how we're going to set this up. I'm going to write out the two equations, 10a plus 6b equals 6, and 4a plus 3b equals 3. And then the way I learned to do it was I'm going to do a big old arrow. I have 2 lines in my arrow. Some people have 1. It's just a personal sort of, style thing. And then I'm going to take advantage of the fact that each of these is a sentence. It is an equation. So we got 2 equations. So I'm allowed to multiply any number times both equations except for 0. Or I'm allowed to multiply any number times both sides of just one equation, except for 0. So watch me as I multiply here by -2. I'm not going to touch the top equation. The top equation is going to stay still. So it looks like that. The bottom equation, I've got to make sure I multiply everything by -2. And this is why we wanted to make sure you practiced all the stuff that came before this, because now this is going to be in your head. -2 times 4a is -8a. -2 times 3b, -6b. -2 times 3 is -6. Now, when we add them, as long as the equals are lined up, make sure the equals are lined up, I get 2a, these cancel, equals 0. So before we go any further, it would be fair for you to ask, how would you know that I was looking for -2? Well, let's look at what I wanted. I wanted something to cancel. So either I wanted the a's to cancel or I wanted the b's to cancel. 10 and 4 can cancel pretty easily. They cancel around the number 20. And we're going to play with that in the next video because you're going to be like, what? So if I multiply the top 1 by 2, that'll be 20, and the bottom 1 by 5. I could make them match. However, with the b's, all I have to do is down here, I have to multiply by 2, and then they're both 6s. Now, if they're both +6, though, when I add, they don't cancel. So what do I do to cancel? I multiply by a -2. That turned this one into a -6. That's what canceled. Okay, so then I've got 2a equals 0. or 2a divided by 2 is 0 over 2. So a is 0. Okay, I'm going to give myself some more room. Come over here. 10a plus 6b equals 6. A is 0, so 10 times 0 plus 6b equals 6. This is a little tricksy, and I know my b's and my 6's come very close to each other. So you may want to do something like make your 6's extra floppy so you can tell what a 6 is and what a b is. Just be careful. 6b equals 6. B equals 1. So my answer is A equals 0, B equals 1. Now, the book thinks that you can put this into an ordered pair. I'm uncomfortable with that. If you wanted to do an ordered pair and it's not X and Y, I was taught you actually have to tell people what your ordered pair is, like what order they come in. Some people, the book included, will assume if you put together A and B, they'll come in alphabetical order. So that has to be, that's a difference of opinion. And then I can check. So let's see. I can check 10a plus 6b equals 6. So 10 times 0 plus 6 times 1, does that equal 6? Yeah, 6 equals 6. Yay! That's the one I don't have to check because this is elimination. That was the one I used. Let's try the other one. 4a plus 3b equals 3. 4 times 0 plus 3 times 1. Does that equal 3? 3 equals 3. You got it. It's done. Woohoo. Okay, so that was the first weird one we did. You may want to take a break, try a couple from the homework on your own, and then come back. We've got a third video coming. The problems are really, really weird. So, maybe take a break right now, go out and find the sun, remind yourself about oxygen and vitamin D, have a dance party with Matt Damon because, there's a solution. He's coming home. Woohoo, we saved Matt Damon. La, 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 la. But we're going to go on, and maybe in the next video, we don't always save Matt Damon. I know. He's not thrilled. He's not happy with me here. He's looking at me like, seriously? Yeah, seriously, you're a puppet. Don't worry about it. Okay, so take a break, do some homework, try some of these, come back for the next video, which is going to be hard. These are going to be harder problems. You guys are awesome. You've almost made it through. Woohoo. Math on, guys. Math on.